Patty Simpson with Simpson Math. Let's find the standard deviation from some data. Remember that the standard deviation is really just finding the average distance that a data point is from the mean. So first, let's figure out what our data is. A technician counts the number of cars passing through the green phase of a traffic light and records the data with the following frequency distribution. So let's write down just what our data is. We can see from our frequency distribution that one car passed through one time, two cars passed through two times, three cars passed through three times, four cars passed through two times, five cars passed through one time, and six cars passed through one time. And one time the light had 11 cars go through it. So this is what our data looked like. This is the data that we're going to find the standard deviation for, find out how spread out that data is. When we're finding the standard deviation and the variance before the standard deviation, we need to know if we're dealing with a sample or with a whole census from a population. So let's look again at our scenario. The technician counts the number of cars passing through the green phase of a traffic light. Did they get all of the green cars? I think not. I think this is just a sample of data. So knowing that this is a sample means that, first of all, just notationally, when I get ready to write down and talk about my mean, that the sample mean is always recorded with an X bar. And then also, when I'm talking about my sample size or the number in my data set, I'm talking about n. But more importantly, when I get ready to find that standard deviation and the variance at the very end, I'm going to divide by n minus 1. So that's really the importance of finding out if it was a sample. If it had been a population, we would divide by just n. Now, I'm going to go through the process of finding that standard deviation. So the first thing we need to know, since we're trying to find the average distance from the mean, we need to find that mean first. So I'm going to find the mean of this data. So again, I'm using X bar because it is a sample. And to find the mean, I'm just going to add up all my values and divide by the number of numbers that I have. Divide by my sample size. So let's add all those up. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 27, 33, 43, 44. So a total of 44 on top. And then let's count to see how many data values we have, what is the sample size, what is our n? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 that we are dividing by. So my X bar, or my mean, is equal to 4. Now I want to find that average distance from the 4. So I like to make a chart to help me figure it out. So I start with my chart. I'm going to put my data values in the first column. Then I'm going to find out the distance from those data values to the mean. Then once I've figured out those values, I'm going to square those differences. So I'm going to take each one of those and square those differences so that my chart looks something like this. Now I'm just going to fill those in. So first my data values here. So 1, 2, 2, 3, 3, 3, 4, 4, 5, 6, 11. Now I'm going to find the deviations. How far away is the data value from the mean? We call those the deviations. So let's find those deviations. So 1 minus 4 is a negative 3. 2 minus 4 is a negative 2. 3 minus 4 is negative 1. We have 3 of those. 4 minus 4 is 0. 5 minus 4 is 1. 6 minus 4 is 2. And 11 minus 4 is 7. Now, I'm going to take each one of those deviations. Before I do that, though, I'm going to check and see if I've gotten my mean and my subtraction correct. Then this column should add up to 0. If it doesn't, then I know I've made a mistake at this point. So I'm going to check it just to make sure. Let's add this up and make sure it adds up to 11. First, I'm going to add those negative values. So that's 5, 6, 7, 8, 9, 10. A negative 10 on that end. Then let's look at the positives. Is 3 and 7 makes 10. So that negative 10 plus that positive 10 will add up to be 0. So it leads me to believe that really is the mean, and I've done my subtraction, found my deviations correctly. Now, I found those deviations. I'm now going to square them so that we can deal with something other than 0. So when we add them together, we don't get 0. So I'm going to take each one of those values and just square them. Negative 3 times negative 3 is 9. Negative 2 times negative 2 is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 7 squared is 49. So I now have the squared deviations. That's what we found, is the squared deviations. Next, what we want to do is find the average of these. We want to find the mean of these squared deviations. So I'm going to find the average or the mean of these squared deviations. I'm finding it from a sample. So when I find my variance, I use this s squared to show this is my variance of a sample. If it had been a population, then I would use a sigma. But since it's a sample, I'm going to use s squared. I'm going to add these together and divide by n minus 1 here. So 9 plus 4 plus 4 plus 1 plus 1 plus 1 plus 0 plus 0 plus 1 plus 4 plus 49. And because it's a sample, I'm going to divide by n minus 1. So instead of 11, I'm going to divide by 10. So let's add all that up. That's 13, 17, 18, 19, 20, 21, 25. I have 25 plus 49, and I'll be dividing by 10. 25 plus 49 then is, well, that's 60, 74 divided by 10. And this is my variance. So I found my variance is 7.4, or 7 4/10 is my variance. So that's the variance. Now to find the standard deviation, all I do is take the square root of that. The square root of 7.4 is my variance. My standard deviation. So I found my standard deviation. Now we can think about what this means. This standard deviation. This tells me the average distance, about the average distance that our data points are from their mean. And we know that this is approximately, well, it's between the square root of 4 and the square root of 9. So it's somewhere between 2 and 3. This number here is something like 2.6-ish. So the average distance that one of these values is from the mean is about 2 6/10. That tells me how spread out my data is. The smaller the number, the less spread there is in my data. The larger the number, the more spread there is in my data. So here's our standard deviation. Square that and you get your variance, these measures of dispersion. Math made simple. It's Simpson Math. Thanks for watching.